Hi, in today's video lesson we're going to look at u-substitution for integrals, and we're starting off with some of the basics. Just to remind you, the earlier exercises in u-substitution are designed to train your mind to spot when u-substitution is a perfect candidate. It requires the ability to do some mental derivatives, power rule, that sort of thing, but what you're going to find invariably in the exercises that are designed to be u-sub is you'll find a function inside another function that is an inner composite. And then if you took the derivative of that function, you will find that value somewhere in some form in the function itself. So for example, the derivative of 2x squared plus 3 is 2x, and so this is definitely a u-substitution candidate. So the reason it works out so nicely is when I establish u to be x squared plus 3, and I take the derivative du dx, I get 2x, which is great. I can just move the dx over to the other side, and I end up with du being equivalent to 2x dx. So this is a change in u, and this is the change in x, and this is how they're related to one another. There's a linear connection. So here, the phrase 2x dx can be written separately, and where the 2x dx exists, I can replace that with du, and where the x squared plus 3 existed, I replace that with u. 1 over the square root of u is easy to integrate as long as we have the right variable of integration, so I replace the 2x dx with du. If I don't change this into du, then I can't integrate the u variable. If this is still dx, then u is treated like a constant. If this is du, then u is treated like a variable. So the language is kind of important, but the goal here is to get a translation of dx in terms of du so we can actually do a substitution and get our du in place. Anyway, the rest of this should be straightforward. We integrate using the power rule. Don't forget to add the arbitrary constant. And then you got to remember to put u back where you found it. U is equal to x squared plus 3, so I'm going to replace the u with x squared plus 3 and the 1/2 power with square root because that's what I was given. And then don't forget to check. You put in the answer that you got. You take the derivative of your answer, and that should get you back to the function you started with. So you can see the green and blue are the same graph here. So just to show you again another example that, this is contrived. It's designed to be easy. I see a function inside another function, so this is under the square root, and if I take its derivative, I get 3x squared plus 1. Conveniently, there's a 3x squared plus 1 hanging out right here, so it's an obvious situation. You allow u to be x cubed plus x, and then du equals 3x squared plus 1 dx. You'll notice I took a shortcut here. The correct way to write the derivative of u with respect to x is du dx, but then we end up moving the dx over to the other side. I will allow you to skip that step just for the sake of, it's the end of the school year. And so anyway, the rest of this then, if I just do a quick little rearrangement, I can see the 3x squared plus 1 dx can be replaced by du. The x cubed plus x can be replaced by u. Now we have an integral where we can use the power rule. It's a really easy integral, so I won't bore you with the details there. Now, the next step is a variation. So what happens when we choose the inner function to be u, like I did here? X squared plus 4x minus 3. When I take du, I get 2x plus 4 dx, and here I see x plus 2 dx. So my goal is to get the x plus 2 dx to become something in terms of du. So I see over here, my target is x plus 2 dx, and what I see here is 2x plus 4 dx. There it's a simple transformation. If I were to take half of both sides of this equation, half of each side, suddenly I see that now I have half of du is equal to x plus 2 dx. So the x plus 2 dx cannot be replaced with du, but half of du. So it's a transformation. That means I can now take my integral and rewrite it in terms of u. So instead of x squared plus 4x minus 3 squared, I just write u squared. And instead of x plus 2 dx, I just write the 1/2 du. Again, simple power rule situation, and you guys can finish that one on your own. Now, don't be fooled when you see an exponential function. You have to remember that the integrals and derivatives of exponential functions are fun and easy. But here again, we see a composite situation. The exponent is itself a power function, so I am going to use that as my u value. And when u is x cubed minus 4, du is equal to 3x squared dx. Now in my equation I see x squared dx, so my target is x squared dx. In order to get this to be x squared dx, I divide both sides by 3. So now I get 1/3 du is equal to x squared dx. The x squared dx can be replaced by 1/3 du. The e to the x cubed minus 4 is just e to the u. Nice thing about this, you can remove the constant to the front of the integral and not even worry about it in the integration process. So I'm really just integrating e to the u du, which is e to the u. Easiest one we got. Don't forget the 1/3, bring that down, and then don't forget to put u back where you found it. One last example. Again, this might be intimidating to the untrained eye, but to the person who is trained to spot the u sub situation, I can see the cosine of x is the composite insiding e to the x function, and I know that the derivative of the cosine is the negative sign, so there's just going to be a scalar difference between these two. Let u be the, oh yeah, sometimes it's good, by the way, to rearrange this. You've got the function that has a composite, and then you've got the stuff that you need to replace. So again, you can train your eye to learn to see this. Anyway, I'm going to let u equal the cosine of x. Du is equal to negative sine of x dx. And then I see my target is 2/3 sine of x dx. So I'm going to multiply both sides by negative 2/3. The negatives multiply out to be a positive 2/3 sine of x dx. So that matches. When I see 2/3 sine of x dx, I replace it with negative 2/3 du, and I replace the cosine with u. Take out the constant, bring it in front so we don't have to clutter our work, and we have e to the u du. Once again, super easy derivative, or integral, both, and then we end up with negative 2/3 e to the cosine of x plus c. I did want to check that just because the graphs look pretty funky. I'm a big fan. So anyway, hope that was helpful. Have a nice day.